We'll work through the solution to statics quiz 11. Here we have a truss. We've got a pin connection here at A, so we can have a Y reaction and an X reaction. At G we have a rocker support, so we only have the normal reaction there. And we're looking for the forces in the members BE, EF, and CB. So here's CB, EF, and BE is here. So we'll use a method of sections to section this truss there, and we'll look at which half we want to use at that point. So our approach here will be one, use method of sections. So two, we'll apply equations of equilibrium. Step 3, we'll solve for BE, EF, and CB in that truss. So looking at our truss here, I've already shown where I'm going to section it, so I'm going to cut through here, and I'll draw another sketch just of the section I'm going to leave here. We could either do the top or the bottom. If I do the bottom, I need to solve these reaction loads, what those reactions are. So that's 3 unknowns. I'd need to do 3 equilibrium equations just to get that part, and then I could go about solving this. If I take the top half, I already have these external loads, so I'm going to pick to do the top half of this. So here's my sketch. And then I'm just going to sketch in where those points are. I don't really need to show that other one horizontal on the bottom there, but here's B, F, E, D, C is over here. Got this 10 kilonewton load. We've got a 5 kilonewton load at D, and at E we have a 5 kilonewton load in the vertical down direction. So there we have it, and we have 4 meters from here from B to C, and 4 meters from C to D, and then in this direction from D to E horizontally we have 4 meters. Alright, so there's my sketch. I'll add that to this here, and sketch, and we get 1 point for that sketch here. So we've got that part done. So step 2, equations of equilibrium. So we have a few choices of where we would want to take our moments about. We could take a moment about B, so then our unknown force BC here would not be applying a moment at B, as well as BE, and our only unknown EF would be exposed then, so we could solve for EF directly if we did that. We could take a moment around F. That gets a little more complicated. We have these two forces here. Could take a moment around E. That would be a equally valid point as to point B. We would have EF would not creating a moment, BE would not be creating a moment, and we'd only have CB. We could solve that directly. Or we could do both around B and E, and then lastly do a sum of the Y forces to get our other component there. So I'm going to sum around B at first. So I'm going to take the sum of the moments around B. It's going to equal 0. So 0 equals. Now what are the things creating moment at this point? So I'm not including this load here. That's not acting on my section since I'm only looking at this. It is being held in equilibrium between these forces in this load as well as the reactions at the bottom here. So I'm going to look at this 10 kilonewton load, this 5 kilonewton load, and this 5 kilonewton load, all creating that rotation around B, as well as my EF force. So I'm going to draw that as a tension coming down here. So some of my moments around B, I'm going to have, this 10 kilonewton load is creating a clockwise rotation, so it's going to be negative 10 kilonewtons times 4 meters. And then I'm going to have this 5 kilonewtons times 8 meters, and that's also going clockwise. So I'm going to have negative 8 meters times 5 kilonewtons. And then this 5 kilonewtons here at E is also going clockwise. So we're going to have 5 kilonewtons, and that's at 4 meters from B. And then I have F, so EF, and that would, as I've drawn it here, as a tension member, is going to be pulling down on that joint. So that will be creating a clockwise motion as well. So I'm going to have negative 4 meters times FEF. So if I do that in math, I get negative 40 kilonewton meters minus 40 kilonewton meters minus 20 kilonewton meters minus 4 meters FEF. So this is 80, 100. So I have 100 over 4, and my 4 is negative here. Kilonewton meters over 4 meters equals FEF. So FEF equals 25.0 kilonewtons, and that is a negative number, which indicates my sign here is backwards, which means that's a compression member. So there's that value. So I get a 1 point here for this equation of equilibrium being correct, 1 point for this value being correct, and 1 point for the compression tension being correct. Alright, so moving from that, now again I have a choice. I can do another moment around E to solve for BC, and I may do that, or I could do some of the X direction forces, and that would get me my BE, and then I could do some of Y forces with all of the forces there. I'm going to do the sum of the X forces next. I may come back and do CB as a moment around E, but we will look at that in a few moments. So some of the forces in the X direction are 0. What do we have going on there? So again, this 10 kilonewton force at B is not applied to our section, so we only have this 10 kilonewtons, this 5 kilonewtons at D, no force from BC, no force from EF, and so we just have the component of this BE force here. So I'm going to draw this 45 degrees in there. This side could also be 45 degrees, depending on how you like to look at that. Alright, and I'm going to draw that as a tension member, so it's going to be pulling down this direction. And that makes sense, right? If we have these two going in the plus X direction, this must be going in the negative X direction, so we'll leave it that way. So sum of forces in X, 0 equals 10 kilonewtons at C, plus 5 kilonewtons at D, minus cosine of 45 times FBE. So that's all the X components that are acting on our section. So I have cosine of 45 FBE equals 15 kilonewtons. Divide both sides by the cosine of 45. Kilonewtons over cosine 45. So FBE then is 21.2 kilonewtons, and that sign is correct, so that means my member is in tension. So that's FBE. So again, we get 1 point for the equilibrium equation, 1 point for the correct value, 1 point for the correct tension or compression member designation. And then for that last member, I'm going to do some of the forces in Y equals 0. So we have 0 equals, what are our Y forces? Let me zoom back up here. So we don't have this 5 kilonewtons, we don't have this 10 kilonewtons. We do have this 5 kilonewtons at E. We have EF acting on that. We have BE acting and CB acting. I'm going to draw CB as acting in tension. If I get a negative sign, that will indicate compression. So we've got, coming back down, so EF is in compression, which means it's pushing on its joint, so that's plus. So I'm going to do that 25 kilonewtons from EF there, minus a 5 kilonewtons at E. BE is down, so I'm going to have minus sine 45 degrees, 21.2 kilonewtons. And then I'm also going to have minus FBC, that unknown that we have there. So if you look at this, if we do this math, we can see we're just basically undoing with the sine 45 times 21.2. We're undoing what we did up here, so this is going to become 15. So you have 25 minus 20. So, and I'm going to pull my FBC to the other side. So FBC equals 25 minus 20, 5 kilonewtons. And since that's positive, I drew it correctly. That's a tension member. So we'll leave that there. Alternatively, for this, so in this case, I would have gotten 1 point for this equilibrium equation, 1 point for the value, 1 point for the tension. So 3 points, 3 points for this value, 3 points for this section, and then the 1 point for the sketch. That's to be my 10 points. Mentioned before, we could do the a moment around E. Let me just kind of scroll up here. So we'll take a look at E. So this would solve for BC a different way. Some of the moments around E equals 0. So we'd have 0 equals, we have 4 meters times FBC. That would be going down, so that's going to be counterclockwise around E. So that's a positive moment. What do we have here at C? That's going through the point of E. At D, we have 5 kilonewtons times 4 meters, creating clockwise rotation around E, so that's a negative moment. And I think that's it, right? So this is creating motion. BE and EF are not creating any motion there. This 5 kilonewtons acting at E is not creating any rotation. This 10 kilonewtons at C passes through E, not creating any moment. So there we are. So we can rearrange this here. We'll pull this 20 kilonewton meters to the other side. Equals 4 meters FBC. So we divide both sides by 4 meters. We get 5 kilonewtons equals FBC. Since that's positive, that means that's in tension. And as a check, we did that independently of how we did it with the Y values. It's the same value, a little simpler method to do that, so we could do it that way as well. So whether you do it as another moment or as the sum of the Y forces, you get the same value. So that wraps up our quiz here, and I hope that clears things up if there were any issues that you ran into. For the most part, people did well. There were a few sections where people became a little confused. Maybe they drew members backwards or something, or added this 10 kilonewtons. That was probably the biggest thing. Sometimes people added this 10 kilonewtons even though it's not acting on our actual section. Where we're cutting it and we're looking at this part, this load is external to that. It's not acting on it directly, so that should not be included in our equations. If we took the bottom section, that one would, but then all three of these other ones would not be on there. What we would give up in doing that is we'd have to solve these reactions at A and G to do that.